This is the summative assessment review for Chapter 2. Problem 17, find the equation and graph for the following table. In this table, the output is increasing by 2 when the input is increasing by 1. So for the slope, you have a rise of positive 2 over 1. So we have 2 over 1, which equals 2. That gives us our slope. For the y-intercept, the b, that's when x equals 0. And if you look at the graph, the b, or the y-intercept, is on the y-axis, where the line, or the graph, intersects the y-axis. So the y-intercept is 2, or b equals 2. So the formula for a linear equation in slope-intercept form is y equals mx plus b. So the m is 2. That's the rate of change, rise of 2, run of 1. You can see it in the graph, and you can see it in the table. And then the slope, the y-intercept, or the initial value, so when x is 0, is 2. So our equation is y equals 2x plus 2. For 18, fill in the table and rule for the following graph. So you're given the graph this time, and you have to fill in the table. So the input is -2, the output is, so -1, -2, output is -1, -2, -3. If the input is 0, 0 on the x, that's going to give us the y-intercept. The y-intercept is at positive 3. So you can see that the output is increasing by 3 for every 1 on the input. So rise over run, the y's over the x's, so delta y over delta x is 3 over 1. So the slope, or rate of change, is 3. And you can see it here on the graph, rise 3, run 1, rise 3, run 1. So our equation is y equals 3x plus 3. For 19, fill in the graph for the following equation. So you're given the equation and you have to graph it. And you can see that it has a negative rate of change. So that means our line's going to be slanting or sloping towards the negative x values. And we have a rise of -2 and run of 3. So here our y-intercept is -2, and we can have a rise of -2, so we're going -1, -2, and a run of positive 3. Rise of -1, -2, run of positive 3. Or we can rise 2 and run -3. As long as one of them is negative, because a negative divided by a positive is negative. Number 20. Luca knows that 15 people are going to vote for him to be class president. On average, he can pick up 5 new voters with every speech he gives. Write an equation in y equals mx plus b form, slope-intercept form, showing how many votes he will have for any given speech. So we know that he's already has, what he's starting with is 15 people, or voters. And he's going to increase for every speech 5 new voters. So the rate of change is the slope. Well, here's the rate of change. This is what's changing. And the b is the initial value, what you start with. Well, he's starting with 15. So in slope-intercept form, he's getting 5 new voters for every speech. X represents the number of speeches, and y represents the total number of voters. And 15 is the initial value, what he started with. So the equation is y equals 5x plus 15. Number 21, Matteo has read 20 pages of his new book on rockets. He reads 3 pages per minute. Write an equation in y equals mx plus b form, showing how many pages he has read for x number of minutes. So again, this is what he's starting with. This is what he's already read. And this is his rate of change, 3 pages per minute. So the rate of change is the slope. B is what you start with, your y-intercept or initial value. X represents the number of minutes, and y represents the total number of pages. Y will always represent the total. So here we have 3 pages per minute, and he started with 20. Because if X is 0, so 0 minutes, 3 times 0 is 20. So that's what he starts with. So our equation is y equals 3x plus 20. Problem 22, use the slope formula or graph to find the slope of these 2 points. Well, using the slope formula, delta y over delta x, difference of the y's divided by the difference of the x's, I labeled this ordered pair x1 and y1 and this x2 and y2. Now it doesn't matter which one you identify as x1, y1 and x2, y2. I could have called this x2, y2 and this x1, y1. But since this was the first ordered pair, I called it x1 and y1. So y2 is 2, so I'm going to plug in 2 for y, and I'm going to subtract y1. But I'm subtracting, so I'm subtracting what y1 equals. Well, y1 equals a negative 2. So a lot of students will make the mistake of just doing 2 minus 2, but that's not what we're subtracting. y1 is a negative 2, so that's what we're subtracting. We're subtracting a negative 2. And x2 is 2 minus, and x1 equals 0. So the opposite of a negative 2, we're going to distribute that negative, is a positive 2. So now we have 2 plus 2 equals 4. 2 minus 0 is 2. 4 divided by 2 is 2. So the slope, m equals 2. For problem 23, use the slope formula or graph to find the slope of these 2 points. So I'm going to use the slope formula, difference of the y's over difference of the x's. So y2 is 3, and we're going to subtract y1, which is positive 1. And then for the x values, x2 is a positive 1, and we're subtracting x1, which is a negative 1. So we're subtracting a negative 1. And now we have 3 minus 1, and then distribute this negative. The opposite of a negative 1 is a positive 1. 3 minus 1 is 2. 1 plus 1 is 2. 2 divided by 2 equals 1. So the slope equals 1. For problem 24, we need to determine if the graph is a function and then identify the domain and range. So is graph A a function? Well, if we look at it, it passes the vertical line test. At no time are there multiple outputs for the same input. For example, the input of negative 1, there's one output, 3. 1/2 of the input, here's the output. So there's never multiple outputs for the same input. So graph A is a function since there's exactly one output for each input, and it passes the vertical line test. For the next part, we need to determine what the domain is. That means the x values, all the possible x values. Well, the x values are all the values on the x-axis. Now, I'm going to show you 2 ways of doing it. One, if you have a solid point on the ends, and then if there's arrows. If it arrows, it's mean it's going forever. So on yours, you have arrows. And so that means that these arrows, it's going to go forever in the negative direction, the negative x's, and forever towards the positive x's. So that means that the x values has a domain of all real numbers. Now, if you were to put points here, and I put solid dots there to represent that it ends here. So if you have points instead of arrows, then our range is going to be going from where they stop. And so this has a domain of x is greater than or equal to -2 from here all the way to +2. It's less than or equal to +2. The range are all the y values. Well, if these were arrows instead of points, it's going to go forever towards the positive y's and forever down towards the negative y's. So the range would be all real numbers. Now I put points here, so it's going to stop here. So our range is y is going to be greater than or equal to -5. This is where there's nothing less than -5. And then our range is going to be y is less than or equal to 5, because it goes to 5, but it doesn't go past 5. So our range are all the numbers between greater than or equal to -5 all the way to less than or equal to +5. 24b, is graph B a function? And explain your reasoning. Well, it passes the vertical line test. And if you notice that there's exactly one output for each input. So this is a function. Now determine the domain, all the x values. Well, again, I'm going to first start, if this was an arrow, that means it's going to go forever in the negative x direction. And if this is the arrow going this way, it's going to go forever in the positive x direction. So that means that the domain would be all real numbers. Now, if you have points, this is where the x values stop, and then they stop here. So it's all the numbers in between here. So from here to here. So x is greater than or equal to 0, here's 0 on the x-axis, all the way to +12. Now to determine the range, all the y values. Again, if we had arrows, it would go forever infinitely in the positive direction for y and infinitely in the negative direction on the y-axis. So that would be all real numbers. But if we have points, that means the greatest value is going to be 1, the least value is going to be -3. So the range would be y is greater than or equal to -3, but less than or equal to 1. So from here to here. Graph C is not a function since there are multiple outputs for each input. So if I have an input of -1, there's an output here and here. So this would not pass the vertical line test. You have multiple outputs for the same input. What is the domain? The x value. So we have, you can see on the x-axis, it goes from here to -3 all the way to +3. So the domain for this one is x is greater than or equal to -3 and less than or equal to +3. It's all the values in between those two numbers. The range, all the y values on the y-axis, well, it's from here to here. So y is greater than or equal to -3 all the way up to here. So it's y is less than or equal to +3.